My name is Mourad Al-Wali. In this video, I will explain the logic behind the solution of the problem 1834b maximum strength from code force. This is the problem statement. You can read it to understand what's your task. But we can say that you are given two positive integers, L and R, such as L is less or equal to R. If the number of digits of L is less than the number of digits of R, we have to add leading zeros to L on the left, of course. We have to find two integers, A and B, such as A and B are in the range L are inclusive, such as A is less than B, that maximize the sum of the absolute differences of the digits on the decimal representation of the integers A and B at each position. Of course, it might that A is equal to L and B is equal to R. Formally, we can say that we have to pick two numbers, A that contains the digit A at position 0, another digit at position 1, and another digit at position N minus 1, and the number B that contains N digits, B0, B1, and B minus 1, such as B0 minus A1. That means that the first digit of B minus the first digit of A, the absolute value, the difference, the absolute value of the difference, plus the absolute value of the difference of the second digit of B minus the second digit of A, plus until we reach the last digit of B, absolute value of the difference of the last digit of B and the last digit of A. This sum it must be maximized. Let's take these two numbers and try to solve it using a naive approach. And using this approach, we're going to understand more the task. All the numbers in this range are 53, 54, 55, 56, and 57. We're going to test each the numbers 2 by 2, which means first we can check 53 and 54. So we have this sum here of the first digit of A and the first and second number, and the minus plus the absolute value of the difference of the second digit of first and the first number and second number. Here the result is equal to 1. We can pick 53, 55. We're going to have 2. 53, 56. 53, 57. Until here, as you see, we have 4 possibilities from 53. 4 possibilities from 53. And we're going to 54 now. 54, 55. 54, 56. 54, 57. We have 3 possibilities. And 55, 57, 56. 55, 57. We have 2 possibilities. Until 65, 57. We have just 1 possibility. The maximum is here, the value is 4. So we can say that the answer A is equal to 53 and B is equal to 57. Okay. What's the number of possibilities here? If I take 53, we have 4 possibilities. If I take 54, 4, we have 3 possibilities. If I take 55, we have 2. And 56, we have 1. Just 2. Okay, the number of possibilities, of course, is 4 plus 3 plus 2 plus 1. 4. We can compute 4. 4 is, how we can determine this 4? 4 is 57 minus 53, so on, which is the numbers of the number of integers in this range. So we can say that for 2 integers R and L, such as R is greater than L, the number of integers is equal to R minus L plus 1. Okay, so here we have 4 integers. We have 5, sorry, we have 5, not 4. But here, to get 4, we subtract 1. So the number of possibility is R minus L plus R minus L minus 1 plus R minus L minus 2, etc. So the total number of possibility is R minus L times R minus L plus 1 over 2. The time complexity of this approach is big O R squared, is quadratic. Then we can compute the number of possibility if we have L is equal to 23 and R is equal to 3,563. We have this huge number of possibility only for this range. If we're going to use this approach, it's very clear here. If we code this, we're going to have a time limit exceeded. What's the logic here of the solution? If I take these two numbers, L is equal 179 and R is equal to 39. We're going to find 3 digits for the first number A and then another 3 digits of the second number A, such as B0 minus A0 plus B1 minus A1 plus B2 minus A2 is maximized. You can say that we can keep this 1 and put 0 here and 0 here. And this we have, and then I will keep 9 here, 9. Why we choose 0 here and 9 here? Because to maximize the difference, the first digit must be 0 and another digit must be 9. For example, B0 is 0, A0 is 9, or the inverse. Okay. But as you see here, we can take this because these two numbers are out of range. So we can choose another approach. For example, L is equal to 199 and R is equal to 200. This way we can maximize the difference, the sum of the absolute values of the differences of each digits of the both numbers. We can take these two numbers, so The answer is 19 here. I think this is the same with the same as the input here. You see, for these two numbers. If I take these two numbers, L and R, so we can keep, for L we can keep 5. Same for R, we have to keep 5. Why this? Because if I pick the first digit, the most digit on the left, the leftmost digit of L, if I pick 5, if I pick 4 or 3, I will be out of the range. Same for R. Same for the second digit, for L and for R. Here we have 1, and here we have 3. What we have to do here? Same for the other. Okay. The next digit here must. Can we put 0 there in that position? The answer is no, because we're going with this number will be less than L, so out of range. Can we put 1? Yes. Can we put 2? 2, yes. But here, which better, 1 or 2? Which 1, because we want to maximize the difference, the sum. Okay, the sum of the absolute value of the differences. So we have to put 1 here. For this side, for R, can we put there? Can we there put the 1? Of course, no, because yes, the number is in the range, but the difference or the sum is not maximized, because 1 minus 1 is equal to 0. Can we put 0? Yes, 1 minus 1 minus 0 is equal to 0. We cannot put 0 because the number will be out of range. Okay. Can we put 2? Yes, but the number is not maximized because 2 minus 1 is equal to 1. Can we put 3? Yes, because 3 is in the range, it will be in range, the number, but it also will be maximized. 3 minus 1 is equal to 2. Can you put 4? 4, no, because we're going, the number will be out of range. So the number must be 3. But for the others now, what we can do for the other numbers? And the first number L, we have to put all 9. 9 on that side and 0 on this side. The number is still in the range, and we maximize the sum. Same for the others, as you see. So that way we have the number R and the range of L and R, from L to R, the first numbers, and we have maximized the sum of the differences of the absolute values of the digits, because max digit here 9 minus the minimum digit is 0. So we can get this formula: 3 minus 1, because 5 minus 1 is 0, 2 minus 2 is 0. So we start from 3, the third digit, 3 minus 1, times plus 4 times 9. 4, it comes from the 4 nines, which is the remaining digits. So, given two numbers L and R as strings, L is less or equal than R, and the number of digits of L is less the number of digits of R. We add leading 0 to L. So L and R now are have the same size. Okay. We run over the both numbers and we check. For example, if we have here the first digit are equal, we do nothing. We go to the next digits. Let's assume that they are equal. We do nothing else. Same with the next digit until we reach a digit or two digits, and both numbers are different. For example, here at position I, Li is different from Ri. What we were going to do here, we have first n minus 1 minus n digits, because here we are at position I, and we have n digits. Okay. Plus 1. This will when we can make this formula if the string is 1 base index, but here the string is 0 base index, so we cannot make plus 1 here, and we have the last digit is n minus 1, so n minus 1 minus I, because the string is 0 base index, and n is the number of digits, and the formula will be Ri minus Li plus 9 times the number of the remaining digits, as we have seen in the previous slide. Okay. The time complexity here is big O, the number of digits of R. Let's take an example. If we have R is equal to 3 and R is equal to 3, 5, 6, 3, we add leading 0 to small 23 from the left. At 2 zeros, because the size of R is 4, to have the same size. Then we're going to maximize these two, the sum of absolute values differences of each digit. So we have here 0 is different than 3, so we're going to make 3 minus 0 plus 3 times 9, as we have seen in the previous slide. Okay, because if we think a little bit here, from 23 to 3563, the two numbers that maximize the sum of the absolute values of the differences of the digits of both numbers, the left must be 999 and the right must be 3000 to maximize the difference. 0 minus 9 or 9 minus 0 is equal to 9. This is the max, which is 9. The code of this, or the function of this solution, the function will take as parameter two strings L and R. We can say from the beginning, if R is equal to L, return 0. It's very obvious here, because both the all digits are the same. So the difference will be 0. We compute the size of the right number, because we have R is greater than L, or equal, greater or equal than L. So we can check, we add leading 0 from the left, which is leading 0, which is the size, minus the left number, the size of the left number. For example, if we have the number n is 5, and let's take a very quick example. L is equal 23, but let's take the same example. R is equal 3, 5, 6, 6. So n is equal to 5 here, and the number of leading 0 are 5, which is n, minus the size of L, which is 2. Okay. Sorry, remember, sorry, n is equal to 4 here. 4. So 4 minus 2 is equal to 2. We have to add 2 zeros on the left to 23. If the two numbers have the same size, so this will be 0. We add 0, 0, 0 to 2. Okay. Now we run over the indices from 0 to n minus 1, and we check when we find a digit on the left is different from the digit on the right number, we return this formula, as we have seen in the previous slides. This is the logic behind this solution, guys. I hope this is very helpful for you. Thank you for watching.